Okay, today we're going to be talking about section 3.3, which are measures of central tendency and dispersion from group data. So here's what we're going to be talking about. We're going to approximate the mean of a variable from grouped data. We're going to compute weighted mean, and we're going to approximate the standard deviation of a variable from group data. Now, objective 1. We had previously discussed how to compute descriptive statistics from raw data, okay? But a lot of times the only available data has already been summarized in frequency distributions, which we're going to call grouped data, okay? So if we're working from a frequency distribution, that is grouped data. It's not the real thing. It's just a description of how frequently things happen, okay? And although we won't be able to compute the exact values of mean or standard deviation without raw data, we can approximate these measures using the techniques we're going to talk about in this section. Now, the first thing we need to do before we can approximate anything is talk about the mean of the variable. And again, we want to talk about population mean mu, sample mean x bar, okay? We have some things that we need to define about this. Now, as you know, mean takes the values of the data, adds them up, and divides by the number of data points. But with frequency distributions, we don't actually have the data points. All we have are population classes, and we have the numbers of times things happen in a population class. Okay, so we are going to approximate, and again, this is not calculating, this is just merely approximating the mean of the variable by doing this. We're going to look at the midpoint of each class. So x sub I is going to be the midpoint of each class. F is the frequency associated with this class, and n is the number of classes. Okay? So, with calculating the population mean and actually calculating the sample mean, we're going to do it the exact same way. We are going to multiply the midpoint of each class by the frequency of each class and add them up. And then we're also going to add up the frequency of each class. And we're going to divide the two. Okay? And in doing so, we can approximate the population mean. I hope that makes sense to everyone. Okay? So we multiply the midpoint by the frequency for each data point or each data class, and then we add them up. And then we also add up the frequency in each class, and we divide the two. We do that for both sample and population mean. So for both population and sample mean, we are going to do the same calculation, which is so here we have an example. We're going to be approximating the mean from a relative frequency distribution. And here we have our classes, okay, and our associated frequencies, okay. And this is a national survey of student engagement. Asked first-year students at a liberal arts college how much time they spend preparing for each class, and the survey results are what we have here. So, first thing we need to know is the midpoint. Well, if we're talking between 1 and 5, midpoint is very easy to calculate. Midpoint between 1 and 5 is 3. Midpoint between 6 and 10 is going to be 8. Midpoint between 11 and 15 is going to be 13. And so on and so forth, 18, 23, 28, 33. Okay, so those are all our midpoints. So we've calculated the midpoints and we put them in this column here, okay? We know our frequencies from our chart, and they're in this column. And the important thing is we want to multiply them. Let me erase this real quick so you don't have to deal with all my marking up the screen. So we're going to take 0 times 0 equals 0. 130 times 3 equals 390. And we're just going to multiply these all up. And then we're going to add the results. okay? And that's the thing that's going to go on top. And then we add all the frequencies, and that's the thing that's going to go on the bottom. And our final x bar is going to equal 14.25. Okay? Now remember, this is just an approximation, but we can still get a really good idea of what's going on even though we don't have access to the raw data. Next, we want to compute the weighted mean. The weighted mean of a variable is found by multiplying each value of the variable by its corresponding weight, adding these products, and dividing the sum by the sum of the weights. Okay? Think of this like you would calculate a GPA. We have different weights for different grades. An A is worth 4 points, a B is worth 3 points, a C is worth 2 points, a D is worth 1 point, and an F is not worth any points. And so when we're looking at these formulas, the W is your weight. If we were talking GPAs, it would be 0, 1, 2, 3, or 4, right? And the I, the X sub I, that would be your grade. So we take and we multiply the weight by the grade. Okay? So if you get you take the number of A's and you multiply them by 4. You take the number of B's and you multiply them by 3. Take the number of C's, multiply them by 2, and so on and so forth. And then you add up all the weights. So 4 plus 3 plus 2 plus 1 would go on the bottom if you were calculating GPA. So let's look at this. Bob goes to By the Way nut store and creates his own bridge mix. 1 pound of raisins, 2 pounds of chocolate-covered peanuts, 1.5 pounds of cashews, and $1.25 for chocolate. Oh, yeah. The raisins cost $1.25 a pound, the peanuts cost $3.25 a pound, and the cashews cost $5.40 a pound. Okay? So in this case, the weight is an actual weight, right? Actually, in this case, the weight is an actual weight, okay? Or you could actually look at it the other way around. No, the weight is not the actual weight. Yeah, the weight is the actual weight. Sorry. And so we take the weight multiplied by the cost, and then we divide it by the sum of the weights, okay? Which gives you the cost per pound of this mix, okay? So 1 times 1.25 for the 1 pound of raisins, 2 times 3.25 for the amount of cashews, 1.5 times 540 for the cashews, and we add up 1 plus 2 plus 1.5 on the bottom, and we end up with $3.52 per pound. Now let's look at objective 3. And this is approximating standard deviation of a variable from group data. Remember, group data is not raw data, so only approximating here. Now, remember your population standard deviation is sigma, sample standard deviation is little s. We are going to be using our approximated mu here and our approximated x bar to calculate this. And we still have x sub I as the midpoint and f sub I is the frequency. Okay? So we take and we subtract each midpoint from our approximate mean and multiply them by the frequency and add all those up for each class. And then we add up the frequencies again and divide everything and take the square root. Now, notice the difference here with the sample standard deviation approximation. Remember our degrees of freedom, so we take that added up sum of the frequencies and subtract 1 for our degrees of freedom. Okay, this is an algebraic standard equivalent, or standard deviation equivalent. Again, this is for mu's approximation, and we might find that easier to use or not. We'll talk about it in class. So let's look at this and approximate. This is the same data from the last time we used the data. Let's look at this and see what it's going to take to approximate the mean. And or approximate the standard deviation of this sample. And here is our formula, and we're going to use the original formula for that. Okay? So we're going to take our x sub I, which are the frequencies, which are the midpoints, and we are going to subtract our x bar from them. Okay? And that x bar was the x bar that we got earlier. Okay? And then what we're going to do is square that and multiply it by the frequency. Okay? So we're going to subtract x and sub I and x bar. And then we square it and multiply it by the frequency in this column. And then we add all those up, and that goes on top. Okay? So we're going to end up with 65,687.5 on top. And then on the bottom, we take and we add up all the frequencies, and we get 1,000, and we subtract 1. So we end up dividing by 999, and we get 65.8. Okay? Now finally we need to take the square root of all of that, and we end up with 8.1 hours. Okay? This would be our approximated variance, and this is our approximated standard deviation of 8.1 hours. And we will do more of this in class, and I will talk to you later. Thanks for listening. Bye.